So let's do another Hess's law. And again, with Hess's law, we want to figure out delta H of the reaction. And the way we're going to do it, we're going to manipulate these two equations. Either we're going to reverse them, or we're going to multiply by a coefficient, or do both, etc. So for this case right here, our goal is to have this reaction right here. PCl5 will form PCl3 plus chlorine gas. And so when I add up these two reactions, I should end up be left with that. So a couple of things, whenever you're doing this, I want to pick either a reactant or product that only occurs in one of these reactions. Like for instance now, let's take a look at PCl5. Well, it only occurs in the second reaction. And notice it's on the products here and reactants here, which means now, okay, I'm going to have to reverse this reaction. If I reverse it, I'm going to change the sign to delta H. So I'm going to make this a positive. So again, you pick one of these reactants or products that only occurs in one of these reactions. It's right here, or it's on the reactant side here. So I have to reverse this reaction. So I'll reverse it in a second. Also notice there's 4 here, there's only 1 here. So I'm going to multiply this reaction by a fourth. So I'm going to multiply everything by 1/4. Because I have to get rid of that 4. So 4 times 1/4 is going to be 1. So it'll be 1 PCl5 here, 1 PCl5 there. And it also means I'm going to divide this by 4. So I'm going to change the sign and divide that by 4. Let's take a look at the other one now. So in this case, I have PCl3. This is the only equation that contains PCl3. They're both on the product side. So this one I'm going to keep the same, which means the sign stays the same. Again, notice though, there's 4 here, there's only 1 here. So I'm going to multiply everything by 1/4. So basically, I'm going to divide this by 4. So I keep the sign the same, but in this case, I'm going to divide it by 4. So I've gone ahead and I've kept this one the same. So this reaction I kept the same. But I've multiplied by 1/4. So I get 1/4 P4 plus 6/4 Cl2 plus, again, this was 4 PCl3. I divided by 1/4, so I got PCl3. The second one, I reversed it, and again, I multiplied by 1/4. In this case now, this is the reactants, and these are the products. So what you want to do is cancel out what's the same on both sides of the reaction. So a couple of things. Notice that the P4s cancel out. There's 1/4 P4s on both sides. They cancel out. Notice there's 6/4 here and 10/4 here. If I subtract that, that's going to end up to be 4 and 4 or 1. So now I end up with 1 Cl2. I add them together now. Maybe this gets canceled out. So I'm going to end up with PCl5 gas, PCl3 plus Cl2. So again, cancel what's the same on both sides. Add up whatever you can, etc. Notice the Cl2s, there were 6/4 here, 10/4 there. That's ended up to be 1. My P4s cancel out. And so this right here is the same as my goal reaction. What I've done is I've divided the delta H by 4, so I get negative 320 in this case. In this case, though, I had to reverse the sign and divide by 4. So I get 443.5. I add the two together, so I'm going to end up with a positive 123.5 kilojoules. So again, it's another way of doing delta H in which I add these reactions together, but I may have to reverse it, or I may have to multiply by a coefficient, fraction, etc.